Problem number one, we have a room with a floor area of 40 feet by 60 feet and a 24-foot ceiling height, has luminaires mounted flush with the ceiling. Determine the cavity ratios. A diagram might be helpful. If we look at the room, this is the top, this is the floor, and go to three-dimensional look. We know that the floor area is 40 by 60 and that the ceiling height is 24 feet. Now there are three distinct cavities in a room. First you have the working surface, which is 2.5 feet or 30 inches off the floor. So this dimension here would be 2.5 feet. And then, depending on where the luminaires are, it may be someplace along here, it may be higher up, maybe lower. In this particular problem, we're told the luminaires are right up against the ceiling. So if they're up here, there's virtually no dimension in here. There's no thickness to the ceiling cavity. So what we're faced with now is if this is 2.5 feet, then this distance in here would have to be 21.5 feet. And there's no ceiling cavity. The formula for cavity ratio says that a cavity ratio is equal to 5 times h, and I've left something out here intentionally, times L plus W over L times W. Which this would be the 40 and 60 foot dimensions. This would be the height of the cavity. Well, the first cavity would be the RCR, and the RCR would be the room cavity ratio. That's the cavity between the working surface and the luminaires, wherever they are. So in our case, the RCR, we put a little R in here now to match the R out in front, and this becomes 5. HRC would be this distance now, which is 21.5 feet. And L plus W would be 40 plus 60, gives you 100. L times W, 40 times 60, 2400. And when we do that calculation, we get a result of 4.48. That's the room cavity ratio. Well, let's do the easy one next. What would be the ceiling cavity ratio? Well, to get the ceiling cavity ratio, we put a C out in front of this equation. And we make this a small c in here, h sub cc, and we proceed as we did before. It's 5 times hcc. Now we're measuring the distance from the ceiling down to the luminaires. That happens to be 0 in this case because of the flush mounting. And since we put a 0 in here, we get for an answer that the CCR is equal to 0. And finally, to find the FCR, that would be the underneath the work surface now, the floor cavity ratio. This would be 5 times h sub FC, and h sub FC would be the dimension, which is fairly standard, of 2.5 feet, unless you're told otherwise. So this would be 2.5 feet, or the 30 inches that a working surface is normally considered above the floor. And when you do this calculation, you get 0.52 for the FCR. So the answers are room cavity ratio, 4.48, the ceiling cavity ratio, 0, and the floor cavity ratio, 0.52. Problem number 2 is similar to problem number 1. We have basically the same room. It's 40 feet by 60 feet with a 24-foot ceiling height. But now the luminaires are suspended 12 feet from the ceiling. So we can put a line across here which will indicate this is where the luminaires are. And that means that while this is still half feet, this dimension, of course, in has given us 12 feet because we're 12 feet down from the ceiling. If this is 12 and this is 2.5, that gives me 14.5. That means that this last part in here would have to be 9.5 feet. So 12, 9.5, 2.5, which add to give us a total of 24 feet.